Hello. In today's video, I will talk about the concept of independent and identically distributed random variable. This is one of the fundamental assumptions in probability and statistics when we prove results. For example, law of large number or central limit theorem or other general results in probability and statistics, then this is the basic framework that we assume. So, first of all, what does a random variable represent? I have mentioned in the very beginning that a random variable is a function that assigns real values or real numbers with the outcomes of a random experiment. So, whenever I have a random variable, there is a underlying random experiment. For example, when I talk about a Bernoulli random variable, then you can think of an underlying coin tossing experiment where x with that random variable counts the number of heads in a single toss of a coin. Now, when we talk about a simple random variable, then there is a underlying random experiment with finitely many possible outcomes, and that random variable is assigning real numbers with those outcomes. So that's how you get a simple random variable. Now consider this, that suppose I repeat the random experiment n many times. Now let us just remember the definition of a random experiment. There were 2 points. One, the experiment has more than one possible outcomes, and outcome of a particular trial cannot be predicted with certainty, but the set of all possible outcomes is known. That was one line, and the other was the experiment could be repeated under identical condition. So when you have a random experiment, you can certainly repeat it. So for example, a coin tossing experiment, you can repeat this experiment as many times as you want. Suppose one particular random experiment is repeated several times. So what can happen? So now with each trial, I can associate a random variable. So x1 will assign numbers with the outcome of the first trial, x2 will assign numbers with the outcomes of the second trial. In this way, xn is a random variable that assigns number with the outcome of the nth trial. Now, since this is the same random experiment that has been repeated, so each since it is the same random experiment, yes, that has been repeated, so each random variable will take same set of values with same probabilities. That is, x1 and x2 are the suppose x1 and x2 represent the outcomes of the same coin toss twice. So x1 will also take head and assign numbers, let us say 0 and 1 with the first toss with the same probability as x2. So when we in this situation, we say that x1, x2, xn are identically distributed. So second point is that when we repeat a random experiment, thus one trial does not affect the outcomes of the other trial. So for instance, in a sequence of coin tosses, whether you get head or tail in the first toss does not affect the next toss. So this is said to be independent. So when you have random variables associated with the outcomes of n many repetitions of a same random experiment, then those random variables are i.i.d, that is independent or identically distributed, independent and identically distributed. So whenever we see the statement that let x1, x2, xn be in i.i.d random variables, that means you think that the underlying random experiment, there is one underlying random experiment that has been repeated again and again. For example, suppose if I say that x1, x2, xn are in i.i.d random variables following Bernoulli distribution, then you think that there is one underlying Bernoulli trial, for example a coin tossing, that has been repeated n many times, and x1 is the number of tosses heads in the first toss, x2 is the number of heads in the second toss, likewise xn is the number of heads in the nth toss. So this is a very important concept to know, because henceforth this concept will be used quite frequently, that let I have got x1, x2, xn be in i.i.d independent and identically distributed random variable. In this case, we also say that x1, x2, xn are n copies of the same random variable x1. So these are just probabilistic terminology. Now why this statement is important, because I will just give you one result. So in my last lecture I had introduced the concept of Bernoulli law of large number. So that was a law of averages for Bernoulli random variable. So now I said that there are general versions of it. So this is one that I will state today, that let x1, x2, xn be in i.i.d random variables. So let us take x1, x2, xn to be in i.i.d simple random variables. That is, each one of them are associated with a random experiment that is have a finitely many possible outcomes. So I have got in i.i.d simple random variables. Then I take their average, that is 1 by n into summation of xi's. So I add x1 plus x2 plus xn divided by n. So what happens to this average as I grow my n, as I observe more and more random variables? That is, as the underlying trial is repeated again and again. Well, this is the law of large number exactly about. So the law of large number tells that as the n is increased, x1 plus x2 plus xn by n converges to expectation of x1 with probability 1 as n is increased. So this is the general statement of law of large number. Of course, I have made an assumption here, simple random variable, because you only up till now have studied expectation of simple random variable, but it could be generalized further. Thank you. In the next talk, I will talk about applications of this result.